Hi, it's me, Tim Dodd, the Everyday Astronaut. There's nothing more exciting than an awesome rocket concept, a new mission to unknown worlds, or an exciting breakthrough in technology. But unfortunately, for every proposal, there's almost an equal amount of cancellations, with only a small handful making it beyond the drawing board. What's even more frustrating is when these concepts actually leave paper. They have thousands of engineering hours put in, hardware even gets built, billions of dollars invested, and then it gets put on the shelf. If this sounds familiar to you, welcome to part 2 of my new Canceled series. We're gonna take a look at some space programs and concepts that were so close to complete, they sometimes were even launched before they got canceled. Oh man, these videos are pretty frustrating. So that in mind, let's get started.
3, 2.
All engine running. Liftoff. We have a liftoff.
Welcome to part 2 of Canceled, where again, we're focusing on hardware that actually flew before it fizzled. It was built and then bye-bye, completed, then canned. You get the idea. There's gonna be a lot more videos coming out in this series, so stay tuned. Remember that so-called space race between the United States and the Soviet Union? Well, despite the US literally moving the goalpost by setting landing on the moon as the end goal, the Soviet Union was clearly beating the United States in almost every other space milestone. So with the moon now being the new target for both countries, the most ambitious and specialized spacecraft had to be designed. So not only did each country build massive rockets with enough capability to actually get spacecraft out to the moon, but they also had to build vehicles which could land on the moon and come home. Of course, the United States built the iconic Apollo lunar module, which rode on top of the Saturn V rocket. But did you know the Soviet Union designed and built the LK, or Lunar craft, to ride on top of their N-1 rocket? That's right. While the world watched as the United States tested and flew their Apollo spacecraft, the Soviet Union was secretly working on a very small lunar lander themselves. The LK was tiny, only about 1/3 the size of the Apollo lunar module, and could only carry 1 cosmonaut as opposed to 2 like the Apollo lander could. Can you imagine? Just a single person walking around on the moon, all alone, completely isolated. That sounds absolutely terrifying. A few fun facts about the LK. First off, there was no tunnel between the LK and the Soyuz 7K L3 spacecraft. So the cosmonaut was actually going to have to do a spacewalk to get inside the LK. The Soviets also had a much different approach to actually landing on the moon. They would first send an uncrewed Lunokhod probe to select a suitable landing area. It would then act as a beacon to ensure precise landing for the LK. Another interesting fact is they would actually send 2 LKs to the moon for each mission. One ahead of time, uncrewed, as a backup if there were any issues with the crewed lander. And this wasn't the only backup to ensure their cosmonauts got off the moon. No, the Soviets were all about redundancy with the LK. The LK actually had primary and backup engines to ensure they could get their cosmonaut off the moon. Now by contrast, the Apollo lunar lander only had 1 engine to get off the moon. And the crazy thing here is this engine could only be started once, ever. So the actual engines used on these missions couldn't even be tested before they fired. And that to me is just crazy. So the one and only time these engines fired was to get astronauts off the moon. If it didn't work, they were stuck. And lastly, the LK only used a single stage to land and ascend from the moon. But it did ditch the landing gear and other structure to decrease weight for ascent. But this again is in quite big contrast to the Apollo lander, which had a separate descent and ascent stage. All said and done, the Soviets had done their homework and had a pretty great little spacecraft to safely land on the moon. But here's the craziest thing. They actually flew 4 of them into space between 1970 and 1971. Although they never took one out to the moon. This is mostly because of their moon rocket, the N-1, had 4 launch attempts, all ending in massive explosions. With no suitable ride to space, the LK never made it beyond low Earth orbit. And with the United States successfully putting humans on the moon, the motivations and funding pretty quickly dried up. And that's not to mention they lost one of their N-1 launch pads, as well as their lead engineer, Sergei Korolev, during the development of the program. So they pulled the plug in 1974. What a shame. I really love this unique approach to landing on the moon. But again, can you imagine being the only person standing on the moon completely alone? It gives me shivers just thinking about it. That would have been intense. Today you can see one of 5 remaining LKs at the Moscow Aviation Institute, the Orevo Research and Educational Facility, the RKK Energia plant in Okorlev, Tambov Air Base Center, or the Military Space Academy in St. Petersburg. We'll talk more about the N1 rocket in an upcoming video about alternate space history, since the N1 never quite made it out of development. I mean, sure, it flew, just not successfully. The Delta rocket. Maybe you're familiar with the recently retired and beautiful teal rocket, the Delta II, or perhaps the orangest rocket currently flying, the Delta IV or Delta IV Heavy, or maybe you're a history buff and remember the Thor Delta or Delta I variants. Lots of Deltas, but what about the Delta III? Why do we hear so much about Delta II and IV? Where's Delta III? Well, there actually was a Delta III, and ironically enough, it's almost exactly between a Delta II and a Delta IV. A very strange looking vehicle, if you ask me. Developed in the mid-90s by McDonnell Douglas and later launched by Boeing after a merger of the two companies, the Delta III was basically a scaled up Delta II. It used that same RS-27A main engine and 2 Vernier engines for roll control, but here's the weird thing. It shared the same 2.4 meter diameter core as the Delta II, but it only had the liquid oxygen in there. And then it tapered up to 4 meters for the RP-1 tank. The RS-27A main engine was too weak to actually lift this bigger rocket, so the Delta III would always require 9 large GEM LDXL solid rocket boosters just to get it off the pad. The Delta III used a new upper stage called the Delta Cryogenics Second Stage, which used liquid hydrogen and oxygen to power an RL-10B2 engine. This engine was pretty special because it offered a unique extending nozzle, which offered increased efficiency while maintaining a compact design. This upper stage offered much better performance when compared to the Delta K upper stage of the Delta II, which used hypergolic propellants. All said and done, the Delta III was capable of taking double the payload to geostationary transfer orbit compared to the Delta II. Now that's impressive. The Delta III first launched on August 26, 1999 from Cape Canaveral Air Force Station in Florida. A software error caused by using the Delta II guidance systems without enough validations caused a complete failure of the rocket when the vehicle ran out of hydraulic fluid used to steer the vehicle. It was destroyed in flight. The next flight in May 1999 failed when the upper stage engine cracked open during its second burn. This is unusual for the RL-10, which is typically a very reliable engine. It's just bad luck for Boeing and the Delta III. The final flight took place on August 23, 2000. It went okay, but unfortunately it underperformed, leaving the dummy payload in a lower than targeted orbit. So despite being within the allowable margin of error for success, it was already too late. With Delta IV coming online and the poor performance of the first 3 launches, Delta III was scrapped to focus on the Delta IV. Although it wouldn't get a chance to be well remembered or loved, it did perform the important work of verifying what would become the Delta IV's upper stage. So at least it did something successfully in its short lifespan. Today, if you're ever driving around in California, you might actually see one of the last remaining bits of a Delta III if you're driving on Interstate 5 in Santa Ana, California. There's the upper stage just hanging out outside of the Discovery Science Center, complete with that extending nozzle RL-10B2 even. Have you ever noticed that Russia loves spacecraft that sort of looks like a shiny ball? At least the Soyuz and Vostok that we're most familiar with are strangely super round. In my opinion, the Soyuz descent module looks more like a delicious gumdrop than it does a spacecraft. Now these are pretty different from the truncated cone shapes like what tends to be more standard in the Western Hemisphere, such as Mercury, Gemini, Apollo, Dragon, Starliner, Orion, etc., etc. But did you know the Soviet Union actually made their own capsule that looks nothing like the Soyuz? I mean, so much so it maybe could have slipped through the doors of NASA unnoticed? Welcome the VA spacecraft. If the Apollo-Soyuz test project made a baby, the Apollo capsule's genes clearly won out here with the VA. But that's not all. They made the VA and there was a large functional cargo block called the FGB module, and together they formed the TKS spacecraft. And this thing was quite big. At 13.2 meters long and 4.15 meters wide, the TKS was even larger than the Apollo Command and Service Module and offered a crazy 7.5 times the internal volume. The TKS was almost a mini space station. but it was actually designed to deliver crew and cargo to the Almaz space station, a secret military space station. Despite that entire TKS spacecraft being much larger than the Apollo Command and Service Module, the VA spacecraft itself, that housed up to 3 cosmonauts, was about 30% smaller than the Apollo Command Module. Most of the volume of the entire TKS spacecraft came from that functional cargo block, which had about 37 cubic meters of volume. Now let's compare that to SpaceX's Dragon capsule, which has 10 cubic meters of pressurized volume and about 14 cubic meters of unpressurized volume, for a total of 24 cubic meters of volume. So yeah, this thing was huge. Oddly, the first 8 VA spacecraft flew on just 4 flights. Yeah, that's pretty strange. They would fly them in pairs to test them in varying re-entry conditions from 1976 through 1979. And they even flew 4 missions with the FGB module and VA capsule, making it the complete TKS spacecraft. Despite all 4 missions going perfectly smooth, no humans ever flew on one. It's really quite a shame. It would have been a really cool spacecraft to see in operation. But at least the TKS design went on to become the basic structure for many space station parts, including Mir modules and ISS modules. The last TKS deorbited on February 7th, 1991, and is probably one of the most well-developed and successful spacecraft that never got to fulfill its true destiny. If you want to see a VA capsule, you're in luck. These things are kind of littered everywhere, including the Memorial Museum of Cosmonautics in Moscow, the Smithsonian Air and Space Museum in Washington, D.C., the International Space University in Strasbourg, and a few other places. I'm guessing we're all probably pretty familiar with SpaceX's Falcon 9 and Falcon Heavy rockets by now. You know, those rockets that land themselves? Yeah, those ones. Well, did you know the Falcon 9 had a baby brother? Or actually, I should probably say an older brother, the Falcon 1. The Falcon 1 was the first rocket SpaceX built starting in 2006. It was a 2-stage rocket with a Merlin 1A or 1C engine on the first stage, and a little engine known as the Kestrel engine for the upper stage. The Falcon 1 came to be when SpaceX founder Elon Musk got frustrated trying to buy a rocket from Russia to launch a small payload to Mars. He was unsuccessful in doing so. So Elon gathered up a small team of rocket engineers, and with his own money and some additional private funds, Elon set off to prove he could build his own rocket and do it even cheaper than he could have bought from Russia. He and his team set their sights on making the cheapest launcher on the market. So, in December 2005, SpaceX rolled their first Falcon 1 out to their launch pad at Kwajalein Atoll on a US military base on the Amelik Island in the Pacific Ocean. It wasn't until March 2006 that the first Falcon 1 took off. The first 3 flights of the Falcon 1 were failures, with some getting frustratingly close to orbit. As a matter of fact, Falcon 1 Flight 3 would have probably gone off perfectly if it weren't for a little residual thrust in the first stage, causing the stages to collide immediately after separation. That's because the Falcon 1 used the Merlin 1A for the first 2 flights, but the 3rd flight they upgraded to the Merlin 1C. And of course they tested the Merlin 1C, but their instrumentation didn't notice a little extra residual thrust after engine shutoff that was really only noticeable in the vacuum of space. So unfortunately, the first stage continued to accelerate just a little bit after stage separation, making it run right into the second stage, which unfortunately caused the rocket to fail. SpaceX was done for. They had virtually zero cash to build another Falcon 1 rocket, but they did have confidence that the vehicle required no hardware changes, just a small tweak to the software. So Elon was able to get a few last-minute investments, just enough to scrounge up for one more Falcon 1 flight. With the entire future of SpaceX riding on those tiny metal shoulders of the 4th Falcon 1 rocket, breaths were held when it launched on September 28, 2008. But fortunately for SpaceX, and of course us SpaceX fans, the 4th Falcon 1 had a flawless mission, putting the RatSat mass simulator into orbit. This made SpaceX the first privately funded company to reach orbit. The success of Flight 4 allowed SpaceX to launch a customer's payload for Flight 5. So on July 14, 2009, the Falcon 1 took off for the 5th and final time, putting the RazakSat into orbit for Malaysia. There were 7 additional Falcon 1 flights on the books, including upgrades to the Falcon 1, which would have made it the Falcon 1E, a more powerful and stretched version. With SpaceX winning a bid from NASA for a medium-class launcher to supply the International Space Station, they decided to cancel the Falcon 1 program entirely and move full steam ahead into their Falcon 9 program. This left 7 missions for the Falcon 1 to be pushed back and eventually flown on Falcon 9s, or canceled altogether. This kind of reminds me of the Black Arrow program from the United Kingdom that we talked about in that first video. It's pretty funny how the Falcon 1 was canceled as soon as it became operational. Only one customer's payload was ever launched, and then they closed up shop. It seems like it ended up being a wise move for SpaceX to use the success of their Falcon 1 to get on over to that Falcon 9 as quickly as possible. SpaceX was probably a bit too far ahead of the small sat curve with the Falcon 1. Had they developed it today with the massive increase in the small sat market, it'd probably be more relevant. This is that same rapidly growing market that Rocket Lab is successfully fulfilling with their Electron rocket. There was one more Falcon 1 built, but never flown, and is now being displayed in a hallway in SpaceX's headquarters in Hawthorne. Now, the last one in this video is a little different because this rocket sure flew very, very successfully. As a matter of fact, it's probably the most famous rocket of all time and fulfilled pretty impressive missions. I'm of course talking about the Saturn V rocket that took us to the moon. So wait, why is it in this video? Well, like I said, this one is just a little bit different, but it's still a really interesting story. The Saturn V is famous for flying 13 times, 12 of them being a complete success, with 9 missions taking humans out to the moon, 6 of which actually landed on the moon. But did you know? There were actually supposed to be 3 more Apollo missions to the moon, and we had already built the Saturn Vs for those missions. Now, we're not going to get into why those Apollo missions were canceled in today's video. That's again for another video about alternate space history. But we'll just say due to budget cuts and changes in direction, Apollo 18, 19, and 20 were canceled. Although 3 Saturn Vs were built for the moon, one of those 3 got put to use by putting Skylab in space. But that leaves 2 other Saturn Vs that are legitimate flight hardware in existence today. If you ever get a chance to visit Kennedy Space Center in Florida or Johnson Space Center in Houston, you'll see bona fide Saturn Vs that are mostly real flight hardware, built to go to the moon. And there's also 2 full-scale Saturn Vs in Huntsville, Alabama, 1 vertical and 1 horizontal. And although neither one is full-blown flight hardware, they're still really, really cool. But fun fact, the horizontal one is the only Saturn V on display that completed a mission. It was the dynamic test vehicle, which was shaken to verify all the engineering of the Saturn V. All other Saturn Vs that completed their missions are resting on the bottom of the ocean. So although the dynamic test vehicle wasn't destined for the moon, it's still an incredible display piece. But there's also the last manufactured S1C first stage of a Saturn V sitting outside of Stennis Space Center at the Infinity Science Center in Mississippi. I wanted to end on this one because I think it's bittersweet. Here are some of the most brilliantly complicated, powerful, and massive feats of engineering ever, with more capability than has ever flown before or since, just sitting there, shackled to Earth by the gravity they know they're just capable of breaking free from. But I also think it's kind of beautiful. I mean, sure, I really wish these things could have flown, put 6 more humans on the surface of the moon on the longest, most science-packed missions we would have ever had. But at the same time, look at this. Now anyone can go see one for themselves. You can even walk underneath or alongside it for a minute or two and admire all the incredible hardware developed for these missions. So next time you're planning an upcoming trip, definitely consider stopping by Houston, Huntsville, Stennis Space Center, or Kennedy Space Center and admire the gorgeous Saturn V. I still get speechless every single time I see one. This all just makes you realize how important it is to have a clear goal, a healthy budget, and strong leadership to really make big things happen. It makes me super thankful for what has been accomplished, but also pretty frustrated at what could have been. If you enjoyed this video, don't forget to check out part 1 if you haven't done so already, but also stick around because we have a lot more coming in this canceled series. Let me know what other questions you have about canceled programs, rockets, or just spaceflight in general in the comments below. I owe a huge thanks to my Patreon supporters for helping make all this stuff possible. If you want to help script or research, or gain access to exclusive live streams where you can ask me questions about rockets and stuff, head on over to patreon.com/everydayastronaut. Thank you. And while you're online, head on over to my brand new web store where I have things like these Gridfin Nada coasters. Notice they're not coasters because they have holes in them. That means the liquid can just drip right through them, but I do promise they'll keep your drink exactly this high off of whatever surface they're on, so they're therefore drink elevators. And while you're there, check out brand new shirts and hats, prints of rocket launches, patches and stickers, and original artwork. Lots of fun stuff on my new shop at everydayastronaut.com/shop. And thanks to you guys, I finally got some of my music available anywhere you listen to music. You can find Maximum Aerodynamic Pressure anywhere. Apple Music, Google Play Music, Spotify, Amazon Music, or even a playlist right here on YouTube. Just search Maximum Aerodynamic Pressure or Everyday Astronaut, and hopefully you'll find it wherever you listen to music. Give it a listen, enjoy. Thanks everybody, that does it for me. I'm Tim Dodd, the Everyday Astronaut, bringing space down to Earth for everyday people.